Okay, hello friends. In this tutorial, we are going to see how to interface your ESP8266 module with Azure Event Hub services. So, Event Hub is a service where we can get an events or any messages from uh, very higher number of devices, maybe say 100 number of devices, onto a common place. Event Hub is usually used for bidirectional communication, where you want your data from your device to the cloud. If you want to have a bidirectional communication, then IoT Hub is the preferred choice. So let's just get started. You need to create three kind of services. First is your Event Hub, of course. So let's just create an Event Hub. Name of We need to give a name of the Event Hub. So let's just give it as know your system. Let's just give it as know your systems, and this is the name of, this is also the name of your service bus. So whenever there is a name of name called service bus, we have to give this know your systems. And pricing, there are I think there are two packages for pricing. One is basic and one is standard. I think we should go for basic just for demonstration. Basic is fine. You don't need more than 100 connections at a time. And subscription free trial and resource group. This is when the first time you have uh, you're in Azure, you need to create a resource group. So let's just call project test project. Okay, location South Central US, throughput unit, let us be one only. So create. Okay, now it is under process. The next service that we are going to do is stream analytics. Okay, what is this? We'll discuss it a little bit later on, but first just let me create a stream analytics job. Let's just give it a name as Noyo. That is fine. Again, resource group. Once we have created the resource group, then you can use the use existing. We are in the test project. So location, it's preferred to have all the services in one location to get less latency. Now there is one more service that we need to add as Storage Explorer. Storage account. Sorry. Storage. Okay, the name is Noyo. General purpose. This is a replication that is used in terms of any you need to have multiple copies of a data. It is for data redundancy. So as of now, locally redundancy is fine by us. We don't have very critical data. And resource group, again, use the existing test project. Location Central US works fine. Okay, so while it is creating, let me just walk you down what exactly is happening. Fine, wait. Deployment is in process. Now we have three services now: an event hub, and Stream Analytics, and one storage account which is currently getting deployed. So what our device is going to do, the ESP8266 is going to send an events or messages to the event hub, and through it will send through HTTP post. Uh, Once we have the messages in the event hub, we are going to use a stream analytics job to get the data from the event hub and store it in a table in a storage account. So at the end of the day, we will have a data in a table in a storage account. So stream analytics is just the middleman over here that is going to get just going to query the data from the event hub and put it in the table. So there's a lot of other things Stream Analytics job can do, but for the time being, we are going to do only this. So it looks like our table storage is also up. As of now, we haven't created any table. There is one more tool you need to download is this Azure Storage Explorer. This is used to visualize, get to see the data, to see our tables. We'll talk more about that later on. First, we'll configure our services. First thing first, let's get joined in our event hub. Now, if you see this is the namespace, I mean, no systems. The event hub itself doesn't have any sections for our device, so we'll add a event in the. We'll create a space to add the events. Let's just call it device one. Partition count, let it be one only. That is, if you are having multiple partitions, I think by default they are having two. Message retention, one is fine. We can't do anything in this. In basic pricing, in standard pricing, you can extend it up till 7 days, I think so. Not sure, but that is just to retain the message inside the event hub. But anyway, we are moving it to the table storage, so 1 day is fine. So one thing to know about is this shared access policy. If you click here, you will get to see the policy. Root manager shared access key. This is our primary key, that is which we are going to use it to communicate the ESP8266 with the event hub. So we need to note down this key and the name of the policy. So let's just see our device space is created. Device one is there, but if you see, there is no policy attached to it. So we need to attach one policy for device one. For the main event hub, outer event hub, it is already attached by default. So just give any policy name. Let's just say policy and let's click manage and create. Oh, I think it is policy, but it's fine. Works fine anyway. So we have the primary key for individual devices also, but since it is only one devices in it, so I wouldn't bother much about it, this key. So let's just get to stream analytics job. Now stream analytics job, as I said before, is just the middleman over here. So we got the input and the output, and this is where the stream analytics comes in. So in the input, we have to define an input. So let's just call it device one. And the name, it's just to be name alphanumeric. Don't add any special characters, because even though it might add, even it might allow, but in the query when you write it, it doesn't allow you to have an alphanumeric characters. So data stream, that is fine. Source, this is where our source is going to be. As I said, we are going to use Event Hub for this example. So our source is Event Hub. If you're using an IoT hub for bidirectional communication, then you can use this. But for our example, we'll use Event Hub. Then this is the name of the service bus and also the name of our main Event Hub. And this is the name of the device which we want. This is the name of the hub where we are going to store the value for the device. So this is the device one, and policy name, letter, keep it as a root access share manager. That I mean the outer. So will the keys that we are going to use it will be for root access manager shared keys. Let just be as JSON encoding UTF-8 is fine, and compression type for simplicity we'll keep it none and create. Okay, while this is creating, let's create an output. We'll just call it as out1 sync. This is where it is supposed to store the output. Now we are getting the data back from Event Hub, so and we need to store it in a table storage. So here the table name, since we don't have any table inside it, so it will ask us to create a new storage table. So I'll just call it a table one. Now these two things are very important: partition key and row key. So partition key is an unique identifier that is each row in our table should have one unique set of data. For example, if you open any Excel sheet, you will see on the left hand side an index column which points and so each row will have an index. Say first will have an index of 1, then 2, then 3, and so on. So this has to be unique for each row. This is to distinguish between the different rows. So one way of doing it is from the source, that is from the ESP8266, attach an unique character, I mean a unique value to each frame that you are sending. So you can use simply as an index number from 0 and keep incrementing it after each frame. So you will get with frame 1 it will have index 0, then frame 2 it will have index 1, and so on. That will work, and you have to just name the variable, I mean just name the field over here. For example, if you're using index, then whatever name of the variable it's that. But there's one slight problem with that, you may soon run out of the count. It may happen that after reaching 16-bit or 32-bit, your counter will overflow and will again start from 0. So that will create a problem because we need to have a unique set of value. Or what if your device is suddenly got reset due to some reason, and it will start again. So it will start again from 0, 1, 2, 3. But that is not allowed because we need to have an unique value. So one approach is to give a timestamp. Timestamp is very much unique. So we'll use it timestamp for partition key. Now, if you're thinking how to get a timestamp, then let's just, for the time being, let's just give any variable. I'll give a variable called XYZ. Now this XYZ has to store a time in it. So for each row, we'll have a timestamp. For each frame, we'll have a timestamp, which is stored in this XYZ variable. And row key, this is supposed to be, this is used when you're sending a batch of data. So consider an example consider this example. We are going to get a sensor data and upload the frame, then read the sensor data and upload the frame again. So this is like a frame by frame transfer where a single frame has a single partition ID. I mean, for in our case, time. So whenever a first frame comes into the cloud, it will have an timestamp, and when the second frame comes, it will have a different timestamp. But when you're sending a batch of data, that is when you are, for example, if you're reading a sensor value from say past 5 minutes, say for 300 seconds you are continuously reading for with considering 1 second, you have collected a sample of say 300 frames. Now you want to send a whole batch of it, so that is known as a sending a whole batch. But the problem is that the entire batch will arrive at the same time, so the timestamp will be the same. So you need to have a different set of identifier field for each one of the frame inside the entire batch. So that is where the row key comes. Row key is the individual identifier in each frame. So if you are sending in 100 frames together, so each of the 100 frames should have certain unique identifier to distinguish in between the frame. Since we are not sending a batch of frames together, we can keep it same as our partition key. So how this XYZ is going to get a timestamp, we'll see that in a moment. And this is the batch size number, but we are going to send one file at one frame, so we don't need to worry. I think maximum we can send 100 frames together, but okay, never mind. Okay, our out is created. Now we'll go with the query. So this is where you define your query. This is the normal SQL query. This is similar to what you write your normal SQL query. So you have your select, and whatever you want to select, you will write here. Star is the wildcard for to select everything. If you want to individually select, say if you're sending and send four sensor values, say if you have it temperature sensor, soil sensor, or light sensor, and you want to store the value only of a temperature sensor, then you can write over here select temperature as temperature, or select soil moisture as soil moisture, and so on. But if you want to write everything, then this star is your wildcard that you are going to use it. Now this is input, and our input was device 1. Okay, and output was out. So what this query means is select everything that is coming from device 1 and give it to out 1, and out 1 is our table storage. So we are kind of exactly storing everything from device 1 to a table storage, which is defined in out 1. And we need to, here we need to mention our timestamp. So there is a keyword for that, system.time. Okay, so xyz is the variable in which our timestamp is going to be stored. And there are a bunch of other cool things that we can do over here. I mean, if you want to have certain conditions on your query, say store the value in out1 only when certain conditions are met, like store the values in out1 only when say temperature sensor gives value of above 30, like anything. So you can use the where keyword. We won't go much into detail about that now. So let's save this simple query. Just close it, and we need to start this thing. Now, now that's all about on the portal. Okay, so let's just check our code. So this is our code. So we need few libraries, the base64 and SHA library. These are the libraries that we need to get it to generate a secure authentication token. So this token is generated from multiple things. One is our Event Hub access key. Your Event Hub access key will look something like this. This something, it will be an alphanumeric. You might have a semicolon equal to or anything. This is just a base 64 kind of key. So you need to get this key, then your policy name and your name of the event hub. That is the name of the service bus and the name of the place in event hub. Okay, so let's just get started. Your event hub. So this is where you will get your primary key. So you need to note down this key. And make sure you don't share this key with anyone. Actually, I'm going to change my key very soon. If you accidentally leak the key, you can just regenerate your primary key. So just copy this key and paste it over here. The second thing is the key name. So this is the key name that we are going to use, the policy name. Then we need to know the name of the service bus. So this is the name of the service bus. I think we have to add an NS. I'm not sure. Yeah, it's know your systems. So, and this is device 1. That is the name of the event we are going to send it to. And this device 1. And then you need to provide your Wi-Fi access point credentials, your SSID and password. Then select the baud rate. There's one more thing that goes into generating your secure token is this expire. So your secure access token is valid only for certain duration. You can define the time for which it is going to be valid. So this is the Unix timestamp. So you have to enter the expiry date in Unix timestamp. So just if you see here Unix timestamp, I've given a time this which is valid till 2024. If you want to have a key which is having a very short uh, time, so let's say if you want your key to be valid only for next 1 week, then you need to modify this accordingly. So this is the current timestamp. If you're okay, now let's get back to the code. So then we have this encoding thing going to happen, and then we have our Wi-Fi getting connected here. This is where our sensor data part starts. For this tutorial, I'm not actually going to connect any sensor, but let's just assume that we have three sensors: temperature and light sensor and a soil moisture sensor. So let's just say temperature sensor is giving a random value between 25 to 45, light is going to get a random value between 10 to between 100, and same with soil between 10 to 70. This is just for demonstration. So these are the three variables that we are going to send, and along with, just for tag, we are going to send a device ID. So we are going to create a JSON packet. So the format of JSON packet is something like this. This is the send event documentation by Azure. I'll just add the link in the description. So this is the JSON body. It opens with a curly parenthesis, then quotes, your field name, and colon, and the value, comma, next field name in quotes, then colon, then value in quotes, and after the last field and value have been inserted, you need to close it using a curly parenthesis. So at the end, you will have something like this. You will have your HTTP request body, and at the end, you need to add uh, your JSON payload. So here is our JSON payload encapsulated between the curly parentheses. So the first field is the device ID, and its value is ESP8266. You can write anything. Then the second field, just don't forget to write this comma after finishing the first uh, field and its value. Then temperature, then quotes, and temp. So we are basically getting a big string of data. We are just concatenating each field and its value. So then request is another big string which has our HTTP body along with the data. So this is the HTTP body, and at the end we are going to add our payload. So it will become more or less like this. So if you observe carefully, this is more like your what we are going to have. If you see the code, this is the HTTP part in it. So this all the values that are going to come from the key. Full SAS is our secure access keys that we are going to get it through SHA-256. And this is the part where we send a request, client.print. Uh, and actually I have commented the response part of it. You can uncomment if you want to debug the code, but frankly it takes a very long time. Uh, we just need, if your application is very, that requires a very frequent updation, say every 1 second you need to push the data to the cloud, then it's better to skip this response code, because we need to wait till further you get the response, and that pretty much takes around 2 to 3 seconds in my based upon my observation. Okay, so now let's just upload the code. Okay, so our code is uploaded. Now let's just check if it is uploading. Now you need to open your Azure Storage Explorer to see whether the values are going to your table or not. So once you have the Storage Explorer open, it will pretty much look like this. Yeah, the first thing you need to do is add your account. Since I've already added my account, so you are getting this. So once you added, you will see something like this: your account name, then storage account, and then in tables, if you expand it, you will get your name of the table. That was the name of our table. And if you open the table, here we'll get all the values. Your device ID, that was that ESP8266, then light intensity, soil moisture, and temperature. And This is the XYZ that has the timestamp in it, and it which was also the partition key and the row key. This timestamp is what is added by the storage account, and this is the timestamp that has been added by the stream analytics whenever the events are coming in. So there could be small propagation delay between the timestamp which is added by the stream analytics and the timestamp which is added by the storage account. So that's all about this. Is one more cool thing before going we can do is to in the stream analytics we can write some conditions in the query. Let me just stop it. I'll create one more output. Out to and I'll create one more table. This partition key as XYZ and okay, so we have out2 here. Now if you go back to the query stream analytics, now you got two outputs, I mean two tables. You can pretty much do send it. Now you can define a condition using where keyword. Say where temperature is greater than 30, and in this case soil moisture is less than, let's just say 40. Just to be sure, let's check whether that is possible. Soil moisture is between 10 to 70. Yeah, that is possible. Temperature is going between 25 to 45, so that is possible. So just save it. So now we are running at different conditions. Just saved. Now we need to run it. Before it run, let's just clear the old table. So table 1, just let me refresh it. Just deleting 75 entries. Okay, it's deleted. Now we should refresh this. So there's one more table that is supposed to come here. If you refresh it, if you know now we get two tables. So now let's wait till the stream analytics job has been starting. Okay, now the stream analytics job has been started. Let's check the table 1. Refresh. Okay, there are values in which the temperature is above 30. It will show only the values in which temperature is above 30. And table 2, okay, it will show all the values where soil moisture is less than 40, I guess. Yeah, and so this is about adding filter to it. And you can anytime, if you want, export this in a CSV format. If you want to plot a graph on your local using this data or anything, you can do that. So that was all about it. Now you know how to connect your ESP8266 using HTTP post through to the Azure Event Hub, and then using the Stream Analytics job to extract the data from the Event Hub and store it in a table storage. So thank you very much. Stay tuned for upcoming video.